Hello, everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we have an expert panel on enterprise knowledge graphs for accelerating data insights. And our sponsors today are Cambridge Semantics, Stardog, and Top Quadrant. For today's presentations, we'll hear first from Dave Stoddard with TDWI, and after Dave speaks, we'll be joined by Sean Martin from Cambridge Semantics, Michael Grove from Stardog, and Nimit Mehta of Top Quadrant for a panel discussion. Before I turn over the time to our speakers, please allow me to go through a few basics with everybody. Today's webinar will be about an hour long, and at the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, you can click on the Help area located below the slide window and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. And if you'd like a copy of today's presentation, click on the resource window for the PDF. Lastly, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or if you'd like to share with a colleague. Again, today we're going to be discussing enterprise knowledge graphs for accelerating data insights, and our first speaker is Dave Stoddard. He's the Senior Director of Research for Business Intelligence at TDWI. As an analyst, writer, and researcher, Dave has provided thought leadership on key topics in BI, analytics, IT, and information management for over 2 decades. Previously, he headed up his own independent firm and served as Vice President and Research Director with Ventana Research. He was the founding Chief Editor of Intelligent Enterprise and served as Editorial Director there for 9 years. With TDWI Research, Dave focuses on providing research-based insight and best practices for organizations implementing BI, analytics, performance management, and related technologies and methods. Please welcome Dave Stoddard, and with that, I will turn it over to you now.
Thanks a lot, Andrew, and welcome everybody. I think we got a good topic today, and also some illustrious panelists and speakers to discuss these issues with. So look forward to a really great webinar today, and thank you very much for joining us. So I'm going to talk about just some research trends and directions to try to set the stage for our discussion of enterprise knowledge graphs for accelerating data insights, and just talk about some of the issues there. I also have some poll questions in there, so be ready for those, because we definitely want to hear what you're thinking in our audience about this topic. And so we'll get a chance through the polls, and then as Andrew mentioned, we'll have an audience Q&A portion towards the end. All right, so let me just click on the right button here. Okay, so rising demands to accelerate data insights. I mean, this is the way it is now. Every organization wants to be more data driven. They want to digitally transform applications. And part of that digital transformation is to make data be a centerpiece, and analytics be a centerpiece of how they execute operations, increase efficiency, reduce costs, be more effective in terms of working, having good relationships with customers and partners, and using data as that language that enables them to create insights that can make a huge difference. So they're looking for new perspectives on the data, need views of all relevant data. This is one of the issues that organizations have been facing, is that, as I'll talk about, is silos and just not getting all the data that they need. So for data science and analytics, 43% say this is their top modernization objective, is just to try to complete those views, particularly as they drive analytics and AI and machine learning and more advanced data science. Taking advantage of diverse data assets, so data is more diverse. There's structured data, unstructured data, semi-structured data, data streams coming in from lots of different sources, log files, location, machine devices. So it needs more than just standard query and reporting. Obviously, we're really kind of at a point where that's not enough. And so uncovering new perspectives is critical, and having the ability to do that. Satisfying business drivers, I mean, I could list many, but I'd list here 2 that we see in our research. One is knowledge for improving customer experiences. Certainly, as the economy maybe becomes more challenging in many industries, it's critical to look at customer behavior, understand what their desires are, what they're looking for, what their buying patterns, how their buying patterns are changing. So all that adds up to the customer experience, that you want to have a good customer experience and learn from that customer experience. And that tends to be, of course, quite a variety of data. Optimizing processes, production, so you have less delays in production, less latency in production, logistics, inventory, the supply chain, trying to make sure things are, again, as efficient as possible and also flexible as things change. And then just the speed of innovation, being able to use data effectively to look at new channels, look at new markets, different kinds of things that organizations want to do to satisfy customers and lead in their marketplaces. So a lot of this is new perspectives on business relationships and, of course, the underlying data behind those business relationships. Organizations are seeking greater clarity through data to understand important customer, partner, and other kinds of business relationships. And so 3 areas that are really critical is context. So you may have transaction data, other kinds of discrete data, but information that's what's the surrounding context of those events, the transactions, what does market competition look like? You don't want to have too narrow a view of that. So, or fraud and abuse. I mean, fraud and abuse networks changing all the time. Different kind of criminal strategies, cyber crimes, and so forth. And so, needing context is really critical. And so, this is often around trying to understand relationships in the data and from that business relationships. Avoiding surprises. Certainly had a lot of surprises in the last 3 years or so in the economy and, looking macroeconomically and the pandemic and so forth. And so without data insights, business networks, your business and your business network, your suppliers, miss signals and trends. So things become surprising, unanticipated, when maybe in retrospect they could have been anticipated if you knew the context and had a better understanding of data relationships and business relationships through that. So results often in higher costs, missed opportunities, often difficulty in customer experiences. Customers are less satisfied. Innovation and resilience. So this is where looking for, again, the new ideas, and we do see in our research this is rising as a concern, is not having the data to understand discovery of the potential for new products and services, how you could adjust to the unexpected with these new products and services. Maybe you have a strategy and need to change that strategy depending on how conditions are changing. So it's important, I think, in these 3 areas to be able to understand data relationships and how they filter up to business relationships. So making it easier to discover data relationships is really a critical thing, and I think something we'll be talking about quite a bit today through the enterprise knowledge graphs and innovations related to that. So analytics, drawing attention to understanding connections between customers, products, services, understanding your business network have better understanding, again, the contextual kind of understanding. Confident decision making depends today on having complete quality views of data relationships. And we do see in our research here, just to finer point on that, need for improved data access across distributed data. Often this data is distributed in silos and it's difficult to pull it all together. So we see here 34% in TDWI research saying making it easier to discover data relationships is a key part of their current data strategy, 42% for the future. So that adds up to quite a bit of emphasis on that point in the TDWI research in our community. 21% are currently satisfied with their ability to visualize and analyze data relationships. So I would regard that as, a number that shows room for improvement. There's kind of a low percentage. 50% seek some improvement, 23% are looking for a major upgrade. So there's certainly an appetite for new technologies, new practices that could be helpful in determining and understanding data relationships. Some of the challenges that organizations face, and we'll again be talking about this more in our panel discussion, traditional BI and data warehousing, it's not delivering enough value when looking at trying to understand data relationships. The value of the data, often you can't see all the data, can't get complete data. So the value of the data outside of that structure and transform data is not realized. It's improving with data lakes and integration into more unified platforms, but a lot of organizations are not quite there yet. They're going to have distributed data for some time. Gaining complete views, as I've been mentioning, is a difficult struggle. 61% say that they're struggling with this. Data is distributed in silos. The data volumes of those silos are increasing. 38% saying silos make access too difficult, and 41% want better analysis for data relationships across sources. So even as organizations are trying to consolidate often into the cloud, almost at the same time, they're generating a lot more data silos, particularly self-service data silos in departments and different functions. This has very important data that's important to get to those complete views. So unproductive data access, analytics, and development kind of plague organizations. It's difficult, particularly for non-technical workers, so the self-service kind of users, the citizen data scientists, to work with. They end up having to, even though they're working with maybe a data catalog, but the metadata is too technical, and so there's a learning kind of skill issue there, and it's difficult to analyze different data in their language, in their business language, in other words, in the language of what they're trying to solve, and there's a lack of agility. So this is all, I think, opening the door to knowledge graphs, to expansion knowledge graphs. Of course, knowledge graphs in many ways have been with us for a while, but I think to accelerate interest in this area, to discover, analyze, visualize complex data relationships. So organizations need better models, they need better systems to make them more easily discoverable. There's a lot of definitions of knowledge graphs out there. We'll probably be talking about a bit in our panel, kind of depending on the direction of where the solution providers come from and what your interest is in knowledge graphs. But essentially, it's basically to capture explicitly how data sets relate to each other. So it's about relationships, and to higher level entities. So relating the data to people, places, things, sort of the three. And unifying the data by meaning. I think this is important too, not by location. So it's not just about where the data is, but what's the meaning of the data, and then, of course, drawing that from lots of different sources. Structures, I borrow this from O'Reilly's, I think it's a good description here, structure that combines business data in a graph and explicit representation of knowledge. So it's also about graphical, being able to see it, because, of course, being able to see the relationships is very powerful and can allow decision makers to work off of that knowledge much faster, and be able to draw conclusions they may not have been able to see without it. So explicit representation of the knowledge is critical. And then accelerating understanding of connections in context. So addressing the contextual issues I mentioned, having the flexibility to see different relationships so you're not sort of stuck with different views and can begin to sort of play around with it and understand it from different perspectives. It's key to the semantic layer, semantic network of real world entities, the people, places, things I was talking about. Abstraction, it shields it. Without knowledge graphs, you're really talking about a lot of very complex SQL. And so, of course, as non-technical users are going to really struggle with that. But even a lot of developers, it takes a long time. And so this is a way to also shield users from a lot of the complexity of trying to build those understanding relationships. Knowledge graphs, catalogs, and then governance. So knowledge graphs are, kind of in the same space in many cases with catalogs. To augment the catalogs, knowledge graphs are helpful. In some cases, they're better than catalogs. And so this is an important area to be looking at if you're investing in catalogs, data catalogs, as to what knowledge graphs could contribute there, or there may be better solutions there. So here we see only 12% are very satisfied with current data catalogs. So there's a lot of room for improvement there. 37% somewhat satisfied, 30% looking for a major improvement. So we do see in TDWI research an understanding this is a critical area, that semantic layer, and with catalogs playing a major role in that. And so looking for a lot of improvement there, and there's quite a focus on that. Problem of integrating multiple or distributed catalogs. So often catalogs are by platform, by application, by database, by data warehouse. And so often you get multiple and distributed catalogs that are difficult to knit together. So this could be an area of a solution of knowledge graphs could be helpful. In TDWI research, we see that 19% want to modernize by incorporating descriptive semantic knowledge about diverse and descriptive data. So different types of data want to be able to pull that in to their semantic layer, to the semantic knowledge they can have either in or alongside the data catalog. And a lot of this is related to data governance. And again, a topic we'll probably be talking about. The data governance, being able to manage sensitive data, know where it is, know how the different pieces of data could come together to create personally identifiable information, which needs to be very well protected from exposures. And of course, it a lot of it is around regulatory compliance, GDPR, CCPA, and others. So it can clarify that kind of oversight you need for sensitive data in your organization. Okay, I've been talking a bit, so let's hear what our audience is thinking. So the first question, poll question is, what is your current level of use and interest in knowledge graphs? So I think it would be interesting to know where it stands. I'm going to try to write these down so we can refer to it later. So number one is we are currently developing and using knowledge graphs. Second is not using them currently, but we plan to use them in the future. Third answer, interested, but we have no current plans to use them. Fourth is we do not yet understand how knowledge graphs will help our project. So you're really here to find out that information. And then E would be don't know or not applicable. So let's take a quick look at the results, and I might refresh it one time just to make sure we get everybody. So it's looking like the number one is 47.4% saying that not yet understanding. But let's go back and just refresh it one more time to make sure we've got everybody. Yeah, the percentage has changed a bit. Okay, so we can see here that just 3.4% are currently developing. It is a bit of a new concept for many organizations. 31% saying they're not currently, but plan to use them in the future. So that's interesting. 17.2% are interested, but have no current plans, but 37.9% saying they do not yet understand. So hopefully our discussions today will bring you some clarity about how you could be using knowledge graphs to help on your various projects. Okay, second question. This is going to get a little more of a drill down here. What objective is most driving your interest in enterprise knowledge graphs? So the first answer would be make more of our data easier and available to use. We do see that, this is really a broad interest in it because data is not easily used or available to use. So that's number one. Second is accelerate development of analytics, AI, machine learning, and use of large language models, certainly a major topic today. Third, improve metadata, data catalogs, and business glossaries. So as I mentioned, it's kind of in that group of solutions. So improvement there through knowledge graphs. Increase scope and effectiveness of data governance and regulatory compliance, as I mentioned. There's definitely a role to be played there for knowledge graphs in improving that area. Answer E is make it easier and faster to develop reusable data products. So we hear a lot about data as a product, developing data products, data sets. It could be BI dashboards, analytics models, things like that. And enabling them to be reusable is very important for the organization's efficiency and moving faster to apply them. And so making it easier and faster to develop reusable products is important. And then developing or building a semantic layer to unify distributed data, such as a data fabric, data mesh. We'll talk about that a bit in our discussion. And then G is not sure, just beginning to investigate. So let's see what our answers are. And again, I might refresh it one time just to get a better look. Okay, so right now in the preliminary look, got about a little over a quarter building a semantic layer, but let's refresh and see if it changes. A little bit. Okay, I think it's pretty stable. So we've got 11.1% saying make it easier, available to use. 16.7% saying accelerate analytics and machine learning, LLM. Catalogs, 11.1%, 2.8% on the governance issue. Would have thought might get a higher percentage there. 8.3, easier and faster to develop reusable data. And then the larger percentages are actually building a semantic layer to unify distributed data. Okay, that's good to know. So that's interesting. So that's top of mind. And then not sure, 27.8%. So got it. Okay, good. Thank you very much. And so let me finish out my presentation and we'll get to our discussion. So flexible models, being able to integrate meaning, as semantic layer is talking about, and all these kind of related technologies and methods that are in there. And so the semantic layer offering business representation above that technical metadata, so to be able to connect it to meaning, the people, places, and things, get to higher level understanding. And so issues that are important that, of course, resource description framework has been around for a long time to interconnect data to help understand relationships, enabling standardized exchange of data, We're all using that whether we know it or not, but RDF, very important standard. And so this is important in knowledge graphs. And then the issue of ontologies. So having that knowledge set, understanding what the meaning is in a larger sense and how things relate together to build that within a domain, how the different data relationships. And so here I quote Ontotext. I think this is sort of a good way of putting a formal description of knowledge as a set of concepts within a domain and the relationships that hold between them. So these are important concepts that are going on in understanding semantic data integration, the role of knowledge graphs, and we'll probably talk about this a bit more in our discussion. 33% we see in our research are interested or want to increase the use of a semantic layer. So all of these things to try to tie together different types of data, understand relationships across different pieces of data, build that kind of understanding within a domain of how these relationships add up to a formal knowledge base, and then be able to use it effectively. So to exchange data, interconnect data, and use standards in particular to make that possible. So just briefly about data fabrics. So knowledge graphs, semantic layer, and data fabrics. The data fabric has been an important concept the last couple of years or so to everyone's got, well, most organizations at least have distributed or disparate data. How can you gain knowledge from all of this data and about the data relationships across the different systems? Critical for data discovery, access, integration, and then governance to be able to govern how that data is being used and combined and affected. Data mesh, so data fabrics and data mesh kind of debated and discussed together, I guess you could say, emphasizing the idea of data as a product, connecting across independent domains. So it leans more on the idea of the independence of those domains and sort of make those domains productive and not have a kind of a heavier infrastructure on top. So the balancing issues there. So distributed, disparate data, and two possible solutions. So knowledge graphs play in this to provide it's a key to understanding connections and relationships, as I've been discussing. So it's going to play a big role in data fabrics and data mesh. It improves adaptability because often data architectures can be rather rigid, monolithic. Legacy architectures tend to be more vertical based on platform or based on a single database system. This is about moving to a distributed network of systems and being able to be adaptable in that network, so because obviously it's going to continue to change and grow different types of data. And about overcoming the silo problems. So hybrid multi-cloud environments are really kind of just adding to this difficulty. As I mentioned, even as organizations are migrating to the cloud, they're actually still generating a lot of different silos, and of course are in process of they have some systems on premises and some in the cloud. So being able to use a data fabric, in particular, the concept of data mesh, and then using knowledge graphs within that can be very important to overcome silo problems, particularly in hybrid multi-cloud kind of environments. So can't get away without showing at least one research chart. So this one is talking about objectives for unified distributed data architecture. So this might be something to refer later to, but I wanted to show, well, at least one stat we have, not on this particular chart, but on a related one, which shows 34% are currently using data virtualization, data fabrics, data mesh. So I brought those all together there. So a lot of this is about data virtualization, being able to sort of have a virtual kind of infrastructure and access to different data sources. So we see 40% using data virtualization for business intelligence, which is a fairly high number. It's interesting. 27% for applications, 18% for data science. And so building from data virtualization to get to the ideas of fabrics is something we're seeing in our industry in the last few years. So looking at this chart, some of the key issues around developing what are the objectives, so simplifying and accelerating access to distributed data. So as I mentioned, that's a key problem. Making it easier and faster to discover data relationships, so central to what we're talking about. And there's some other issues on here, but just to pick out a few, unifying data governance is critical, and then the semantic layers. So we see use semantic layers and data catalogs effectively across or for cross-domain data location, access, and management. So there's other issues on here that are important to each organization in our audience. All right, one more poll questions here. Actually, I think I've got two. So what is your biggest challenge? So this is something we'll talk about in our panel discussion. in adopting enterprise knowledge graphs. So the first is concern about whether we have the talent, skills, and training. Second is understanding how to tie adoption to business outcomes. So that's often a case of trying to bring in a new concept or a new solution. Is the very first question is, how can this help us reach business outcomes? Third is concerned that knowledge graphs will not be scalable and flexible. So some of the issues that need to be resolved about before deploying them. Understanding how to integrate enterprise knowledge graphs with existing systems and applications such as your BI, data warehouse, data catalog. And then E would be just other. And so we'll take a look at that. If you just fill in the ask a question box and supply an answer there, we can discuss it when we get to the audience Q&A. Okay, let's take a look at the results. And again, let me refresh one more time, make sure we've got everyone. Okay, so the answers are, we see almost 20% saying concerned about whether they have the talent, skills. So we'll talk about that in our panel. 42.3% saying understanding how to tie adoption to business outcomes. And so we'll be talking about some use cases and how to answer that question. 3.8%, so just a small percentage saying concerned about them not being scalable. So that seems to be not an issue particularly. 23.1%, so almost a quarter saying how to integrate with the existing systems. So definitely an important issue. And 11.5%, okay, good. So we've got some answers that we'll take a look at in the audience Q&A. And one more poll question. It's TDWI, we love to do research, so why not do it right now? So the question is, which business area is the primary driver of your organization's current and or planned use of enterprise knowledge graphs? So this is just trying to get a scoping idea of what would be the main area of interest in your organization. So asset or content management and search, so being able to find assets, find pieces of content, use search effectively, more effectively, I should say, using knowledge graphs to improve taxonomies and organization of the information. Second would be risk analysis and fraud and abuse detections. As I mentioned, this is a concern, and being able to understand how that's working, in particularly in distributed networks. Third, customer-centric operations, so marketing, sales, support, trying to understand customer knowledge or gain customer knowledge so you can improve customer experiences. Fourth, supply chain, inventory, and manufacturing. So there are lots of distributed data, different types of data, increasingly voluminous data, and then data, of course, spread often across silos, maybe silos across business partnerships. And the business development and competitive analysis, so trying to innovate there, trying to understand the competition, understand the marketplace, get understanding of data relationships there can be very helpful. And then finally, again, use the ask a question box to supply an answer if you have some other focus. So let's take a look at the answers. Let me again refresh. Yep, stable this time. Okay, so 22.9%, so almost 23% saying asset or content management search, 2.9% on the risk. So just about 3% there. 34.3%, it's probably our largest percentage. Customer-centric operations, so that's not surprising. That's often where organizations need to be focused on this. 8.6% supply chain, 11.4% on business development, and then good, we have some answers that will also be supplied there. So it looks like the top one is customer-centric operations, although we do have almost a quarter saying asset or content management search. Great. Okay, well, thank you very much. And Andrew, I'm going to hand it back to you to introduce our guests.
Thank you, Dave. That was a great presentation. Before I introduce our panelists, just a quick reminder to our audience, if you have any question, you can answer it at any time in the Ask a Question window. We will be answering audience questions in the final portion of our program. Now it is my pleasure to introduce our expert panel. And our first panelist today is Sean Martin with Cambridge Semantics. Sean is an award-winning technologist and is the founder and CTO of Cambridge Semantics, and has been a trailblazer in internet and semantic web technology innovation since the early 90s. With a focus on next-generation software and networking technologies, he played a pivotal role at IBM, leading their advanced internet technology skunkworks group for 15 years. A pioneer in defining SOA, Martin boasts numerous internet firsts, including IBM's first web application server, and has contributed to multiple patents and life science journal articles. His experience at Cambridge Semantics covers multiple aspects of starting and growing a software company, including holding various titles from president through to co-lead dishwasher. Our next panelist is Michael Grove with Stardog. Michael is the SVP of Engineering and co-founder at Stardog, where he manages their world-class engineering organization and helps shape the direction of the Stardog Enterprise Knowledge Graph. He has over 15 years of experience in the AI, semantic technology, and graph database fields. Prior to Stardog, Michael performed research on the use of graph-based technologies in pervasive computing environments while at Fujitsu Labs of America. Michael is a graduate of the University of Maryland in computer science and an alumnus of MindLab, a seminal research group in semantic web technology. Our final panelist today is Nimit Mehta. Nimit is the CEO of Top Quadrant. Its flagship product, TopBraid EDG, is a powerful knowledge graph creation and curation tool for data governance and solves important safety, security, and discovery problems for the world's largest organizations. Prior to Top Quadrant, Nimit guided companies through rapid growth as operating executive, entrepreneur, and investor, and holds degrees from Stanford and Columbia. Please welcome all of our panelists. And with that, Dave, I will pass it back to you to begin the discussion.
Great. Thank you very much, Andrew. And thanks again to all of our panelists. I think we've got an amazing group of folks here today, so it's great to have you. I think just to start, though, just to make sure everyone is kind of familiar with your companies and what you're doing, it might be good to just get, just to hear in a nutshell what your solutions and approach are. So you could just take maybe a couple minutes to do this. And Sean, why don't I start with you? You can just tell us a little bit about it.
Thanks very much for having me. And great pleasure to be here. It's a kind of a watershed time for knowledge graph technology, as I'm sure you're going to hear. So my company, Cambridge Semantics, we really have a knowledge graph platform. It's built on a data warehouse, a graph data warehouse. So it's massively parallel, a bit like a Snowflake or a Redshift. And it's built for OLAP, so analytics. And what makes it special is you can actually integrate data in the graph, as opposed to more being a graph being a destination for integrated data. We actually expect you to be able to integrate data in the graph, whether it be through virtualization or materialization. We provide all the tools for you to do that, and then to also consume the data on the other side. So that's in a nutshell what we do. And the system's called Anzo. You can see my T-shirt there. I'm actually advertising it.
Great. Okay. Thank you very much. Mike, how about you? If you could give us just a bit of a description.
Yeah, hi, and thanks everyone for joining me. I'm Mike again. So the Stardog platform, I would say we're not like anything else. We were built purpose for this problem. David, you did a really great job of summing up the challenges that Stardog was built and designed for. I think the audience did an even better job in talking about the things they were thinking about using knowledge graphs for. 40% said either driving LLM, data science ML, or distributed data challenges. What got us started. You add in catalogs, that's over 50% of the audience, 2/3 of the audience. You add in data easier to use. That is the goal of our platform, top to bottom. We have a high-performance graph database, virtualization layer. We'll access data where it is. Very easy to use UX, and LLM-powered agent coming out soon that I'm pretty excited about. We'll hopefully talk more about later.
Great. Nimit, how about your company at the Top Quadrant?
Yeah, thanks again, Dave, and good to be here with the audience and the panel. Similar, it's Top Quadrant. At Top Quadrant, we help a majority of many of the Fortune 1000 manage data to really improve data governance, usage, quality, reusability, et cetera. And we do it through knowledge graphs. And I think one of the questions the audience was asking is really understanding. We go from soup to nuts, helping folks understand what knowledge graphs are, all the way to really deploying them for real business value. I loved how the audience is talking a lot about how do we tie this to business value. Our flagship product, TopBraid Edge EDG, is a powerful knowledge graph. It's the most powerful knowledge graph editing tool enabled for data governance. We not only help create knowledge graphs and help companies really define and design them, we enable collaborative curation to broaden the tent of how knowledge graphs capture information and meaning, and most importantly, consumption. So enabling through open APIs and easy to use infrastructure, broad consumption of these semantic tools that end up becoming enterprises' most important and valuable assets, storing metadata and data. So,
yeah, okay, great, thank you, Nimit. Well, I gave kind of sort of bare bones description of knowledge graphs, but I'd be interested in maybe how, if you define it differently, and whether you see that definition changing as users work with it. And so maybe I could just open that up. Nimit, start with you, I guess. Is there more flavor to the description of knowledge graphs that should be out there, I guess you could say?
Yeah, knowledge graphs are one of those words that get used in many different ways. Mm-hmm. Fundamentally, there's two uses of a knowledge graph. Knowledge graph is just a data structure. It's a way data can be stored and information can be stored in a unit, similar to a table. For the audience, we see knowledge graphs as really, there's two categories. One category is where you're storing data in kind of nodes and edges, and really having two entities that are connected with a relationship. That's all it is. Done over and over again, you get a knowledge graph. And the first category is using knowledge graphs to capture real instances of the world. So Dave and Nimit are friends. That over and over again, you create those are the building blocks of a knowledge graph. That's actual data. There's another version, which is metadata, which is how each of the concepts of your organization are interconnected. So when we think about cancer and oncology and being similar to concepts, those are data elements, or social security number and SSN being the same thing. Those are elements related to metadata that we see organizations using. The knowledge graph itself doesn't have much genius behind it, but the structure built, curated, and deployed enables large organizations to actually really understand and use and reuse important concepts all across an organization.
Great, thank you. Mike or Sean, if you had anything to add to sort of just defining what they are.
I think one element, I think there's graph and then there's knowledge graph. And I think if you just think about the graph structure, there's many databases out there that are just graph databases. But I think Nimit is actually thinking about this implicitly given their business. But really what makes the difference for us is the use of ontologies, the semantic layer. And that sets what our companies do, the three of us on this panel, to most other graph companies. We try to capture a representation of the business domain, which for the data we're representing, we try to capture that in a way that is as true and as intelligible to the human as possible. And the means we use for doing that is the ontology. And I think you really do need to have graph plus ontology together to make a knowledge graph. So that would be my sort of nuance on what Nimit said.
Yeah, and I agree with everything that Sean said. I think that's a good summary. David, you hit on it really well earlier. Context, I think, is the key. Graph databases, the market matured past graph databases because 32 is data, 32 feet, which is a particular measurement of something in my logistics chain, that's knowledge. And that's the difference between graph and knowledge graph and data and actually getting insight that drives your business forward. I do want to quibble with one thing that Nimit said, though. I don't think there's any distinction between data and metadata. Metadata is just data for another use case. And I think the mindset of thinking of them as separate has held organizations back. And they have to think of them as a more holistic, complete picture to actually leverage their data effectively.
Yeah, I couldn't agree with you more, Mike, on that. Metadata is so important, and you can't tell the difference between instance data and the data that describes it in a graph, and you shouldn't have to. It's just whatever the query shows up, that's what you're going to get. And you want knowledge graphs really do represent a way to bring what are currently often very disparate systems where the metadata describing the data is very separate. A knowledge graph gives you an opportunity to bring the whole thing together in a way that is manageable and scales from a process point of view.
Well, good. Maybe we could talk a little bit about use cases. So what would be just an example of a major use case? What kind of challenges are they trying to address by applying knowledge graphs and the technologies. Mike, why don't I start with you for this one? What would be sort of a good classic use case in your customers, among your customers?
I'll talk about what I don't know if it's classic. It's our original use case. I think it's the coolest one. One of our longest customers is NASA. They use knowledge graphs in the Artemis project, which is the return to Moon and Mars.
Wow.
And they're basically strapping humans on top of the big bomb and exploding it very gently, and hope they end up in outer space. So they're using knowledge graphs to verify that that is safe to do. You can only shake someone so much. You can only subject them to so many G-forces. So they're taking advantage of the power of the fact they have all this data, all this engineering data, how these parts were built, the bombs, how they're actually ended up on the spacecraft when they were last serviced. So knowledge graph is bringing that all together and giving them the visibility they need to say, yep, it's safe to send these people up on the spacecraft and take the next step in space exploration.
So that's really an enormous knowledge graph, I would think, and rather complex, probably.
I would say complex, but not enormous. I mean, that's the other data misnomer. You don't have to have big data for your data to be valuable. NASA's data is super valuable because the difference between success and failure is people dying. So they have the right data. They don't have lots of data. They have the right data. And I think that's an important distinction. Organizations prioritize collection over connection. And they end up with piles of data they don't know what to do with, can't leverage, that are hard to get value out of. You just don't need that much.
Yeah, that's a really good point. And probably, thinking about the insights that knowledge graphs can provide can help organizations maybe realize, or get value out of the data that they have, and maybe the other data they don't need to really be storing. So, Nimit, maybe you could describe a customer among your customers. What would be a good classic customer?
Yeah, of course. There's a lot of hope and promise on what knowledge graphs can, and in the sense of possibly will be able to achieve. We spend a lot of time on what actually is happening across some of the largest organizations in the world. And frankly, some of that is really complex, potentially not super sexy, but really important data management workflows. So we think about policy management and security and data security and privacy a lot. It's been something that has been elusively driven at the largest media, social media, and financial services companies we have. So very simply, how do you make sure that you can move a data asset from one geography to the next, from one AWS server across an ocean? You have to know not only what the data holds, but at certain volumes, really, how can you do it at a velocity that doesn't slow your organization down, so that you can turn really important policies into company assets. And so GDPR, CCPA, even boiling it down to define what is personally identifiable information. 10 years ago, it was your social security number. How do you manage 15 different definitions? Now it's your name and the company you work at. I can identify who you are. Over time, it'll just be a set of features in an AI model that I can identify an individual person. And using that, backtracking and saying, hey, how do I make sure that I can move an organization? I can move my customer list from Germany to the US. And so it's incredibly important for business and analytics. It's incredibly important for data science, and it's kind of one of the most simple and I think complicated use cases that knowledge graphs makes incredibly easy.
Great. Sean, how about at Cambridge Semantics?
Obviously there's many, but one that I like very much is something we did with the FDA, who have a lot of use cases. But there's one in particular that I like, which is where we sit on top of we basically sit on top of the about 14 systems there, pulling all the data that I don't know if people know this. When you interacting with the FDA to get a drug approved, your submission is broken up and passed into many different groups at the FDA who are expert in all the different aspects of it. And what they really wanted to do was have a simple way to cut across all of that data and create a single view of the drug and drug application. So everything that you know about this drug, and in fact, the entire history of all drugs going back to 100 years or something. So that is built up out of 14 systems, underlying systems. Some of them have very Byzantine schema, and we're able to now let the end users at the FDA across all these different departments very quickly understand immediately where any particular drug or drug family or adverse events or any really dimension related to a drug and a drug application and its processing through the system, where that is at any moment. And this allows them to be able to answer questions very quickly. And a lot of those questions are coming from Congress. So things that used to take weeks could be done in a few minutes. And kind of ironically, we deployed this during COVID in the first year. I think it was in the first year of COVID. So we felt like we were doing a very good thing. So that's a good example of a system that just pulls together a huge amount of complex data and puts a navigable front end on it for end users. And knowledge graphs are fantastic for that. Think about how complicated all that data is, all the hundreds and hundreds of relationships, the hundreds of different types of things you want to stitch together. You can do that with the knowledge graph and the right ontology. So that's a very good use case.
And otherwise it'd be so complex it would take a lot longer. So probably a lot of latency that could be removed, in other words.
What's actually so nice is that they have many other use cases, and the ontology essentially is describing the data that they have, right, mm-hmm. in a way that is human understandable. So, and now we don't have to think too much about the next use case, because either they've got the data there and we can just plonk a dashboard on top of it, or you realize the data isn't there, in which case you've got to find one edge that connects to this new data set, and now that data is also there, and it is, right. You can just plonk a dashboard on it. So it's a perfect technology for essentially, once you've done the work of building that model, that ontology model, you can put all sorts of we call them lenses on it to look through it. I imagine in my head as a huge pile of facts, right? A massive pile of them, and any use case is simply a flashlight or the query shining through that, and the facts that actually you can see, those end up in something that the human sees in a dashboard, and that's the use case. Simple as that.
Great. Well, what about skills? What kind of skills do folks need to be able to start using this? If they have maybe experience in BI and analytics, how can they incorporate this, I guess, in their projects? Sean, maybe we'll start with you.
Well, my answer is going to be changing over the next little while. But the first answer, the answer up until more or less around now, was the skills are pretty analogous to the ones you already have. If you know how to do schemas, you can almost certainly figure out how to do conceptual models and ontologies. There's still ETL, there's still ELT, there's mapping. All of those things have a pretty direct analog. There's a query language. It's like many query languages. And dirty data is always with us. So many of the problems are the same ones that people already know and hate. And what's going to change, and I'm sure Mike will be talking about this given his recent announcements, but what's about to change is the LLM technology from OpenAI and others is really going to completely transform our ability to automate the creation of not only the graphs, but the ontologies as well. And it's going to be highly assistive. You've almost certainly, people have heard how Microsoft have a product called Copilot, which you can put into Visual Studio and so on and help you do coding. But that same technology can be used to greatly simplify the creation of the knowledge graphs. And you're going to have far more reason to create knowledge graphs too, because, and I think this is really a watershed moment for my colleagues and I on this call, because really we're seeing now for the first time a technology that can accelerate or pull what we do into a mainstream like we've never experienced in the 2 decades that I've been working on it, because we have a technology between us that where we're essentially describing data in the way that a human thinks about it. And if you think about the LLM technology, it's essentially human questions that need to be translated into queries, and those ontologies are a human machine readable form that is that sort of map. And suddenly the downstream use of the data is about to be accessible in ways that we could not have imagined 6 months ago or a year ago. So it's really knowledge graphs are about to meet their true killer app, is my opinion.
Wow.
We'll be interested to see what my colleagues on the panel make of it, but I'm sure they're rubbing their hands together in glee right now because
for sure,
it's such an amazing thing for what we do. It really makes sense of everything we've been working for decades. I'm interested
Let's
to hear.
keep talking about that. Mike, I saw you had a great blog recently about this topic, so I'd like to get your views on it. We'll come back to the skills question in a moment, but let's talk about LLM and where that's all going. Sean, that was great. But Mike, what's your take on that?
Yeah, I agree. It's a watershed moment. This technology connects the world of human understanding and meaning, us having a conversation today, with, as Sean was just saying, the machine of world understanding that the three of us, our respective companies, have spent 20 years working on, and it bridges the gaps. And now humans can very clearly and concisely describe what they need from their data, the knowledge that they're looking for, the insights they're trying to get, and actually have something that understands on the other end. And that not only can translate that into a black box and give you an answer that's maybe hallucinated or not. No, we have access to the data. We can tell you what query was used to get the data. We can tell you where it came from. This data governance still matters. The catalog is just data is just metadata, and metadata is just data. So we can tell you where the data came from, who last touched it, who the owner is. We can give you an email, someone to be angry about if you don't like the answer you got from the LLM. So it really also fills a gap in explainability in AI, which is something that I think we've been struggling with. So we're very excited. We have an agent like Copilot that'll sit in the tool with you and build your models. It'll build your mappings. It'll build your business rules. You just have to describe to it what you want. Trying to encode me and all of our other smart folks that know how to use Stardog, know how to use knowledge graph technology into an agent that can act on the user's behalf, who doesn't have the skills, doesn't know the particular details of knowledge graphs and how they work, how to optimize them. They know their business, their SMEs, they understand their domain. You said it earlier, David, using the language of their business to talk about their data. It's real easy, real quick. Because I can talk about it in English and get an answer from a machine that understood precisely what I meant. And Nimitz said earlier, business is moving fast. That was true. Everything's going faster. Data's just got that much more important, and being able to move as quickly as humanly possible is equally more important.
Great, thank you.
LLMs just make knowledge graphs more foundational.
Wow. Well, I think that is some news.
I think one thing to add one thing to add there is not to jump onto the same excitement chain, but we totally see the same thing. The one area is that with LLMs, one of the biggest, probably for the past 15 years, the quip against, or the gripe against knowledge graphs is that they're hard to build and they're hard to kind of manage and they're a little bit unwieldy. And we've all built businesses that kind of helped do that in certain ways. And the approach to actually having LLMs to enhance a steward or an SME to actually get information and meaning imbued inside a graph has never been, or is going to become significantly easier. RDF still is required. You still need to have your roles and responsibilities. You need to define governance. You need to define your users. But the ability to get meaning stored incredibly fast at an increasingly higher precision is going to accelerate the ability for higher quality semantics, higher quality, this whole thing around semantic layers to be able to drive outcomes, and then your ability to actually deploy across an organization. So talk about having your whole enterprise speaking in the same language. It's easy with 30 people. It's incredibly difficult with 3,000. And the ability to have semantics to define what we all mean by this concept and have it be driven across an organization is never going to be, it has become significantly easier.
Amazing. That'll be interesting to see. We could talk a bit about how they work with enterprise data catalogs and that kind of layer of technologies. I think we did see a lot of interest, at least in our TDWI research, in the role of knowledge graphs in data catalogs, or alongside or better than data catalogs, whatever it may be. Nimit, why don't we start with you to answer that question?
That's great. I mean, we see a lot of data catalog. We call it the data catalog graveyard. Data catalogs are great. They're important, and they're a really important building block and step for the maturity of an organization to help make data discoverable. I think the root of it is just the difference between querying and search. Mike talked a little bit earlier on what is meaning versus data. And the idea is that data catalogs are really important. They're at the base of it. They're effectively a user interface for a table. And they at some point, they're just about making a tag set more discoverable. So if data asset has this tag associated with it, return it to me. That's a query. Search is very different, which is if data asset has this concept, and if a concept is related to cancer, I want to get things that are related to, think of Google. Think of the way that you look at a search engine. From cancer is related to oncology, it's related to, tumor, all these things. When I'm thinking about cancer, I want to understand the full contour of how my organization understands that data concept. That's search. And at the end of the day, a data catalog helps you do really good queries. It's a very good query engine. Semantic data catalog is about search. It's about enabling the conceptual understanding of what I am trying to look for and giving me in real time in the best understanding that my organization has clarity. So I guess the relationship with the knowledge graphs are, we see this very often, they enhance a data catalog, enabling it to be more intuitive, the way your brain thinks. So you don't need to have 30 different queries to get the one search that you're trying to get done. And then second, we have a highly intuitive data catalog that's stored and built directly on top of a knowledge graph, because at its core, a knowledge graph is just capturing concepts that matter to you. And so, those are the two real things. And I think they interact in a really symbiotic way, but at times really can be enhanced by actually being built upon directly querying and understanding your data through a graph.
That's great. Yeah. Sean or Mike, do you have any thoughts about that relationship between catalogs and knowledge graphs?
For us, it's very simple. They're a source of data that describes other data that we can use to make more understandable graphs, so our users can query that data. I know that you could certainly build a catalog on a graph or a knowledge graph, and that's useful, but it's not really where our sweet spot is as a company. We're interested in bringing all that data together into one place so that it is all there to drive query. Ad hoc query, by the way, not query that way you've got a pre-plan where the direction of the query. We just expect to be able to run any query in any direction against that data. And metadata simply makes that data more understandable. If metadata catalogs are a source of data amongst many other sources.
Mike, I don't know if you want to address that question.
Yeah, just add one thing about catalogs and how they relate to knowledge graphs. I pluralize the word purposefully because organizations there's no catalog. There's no enterprise on earth that has one catalog. There's 11D. And it's Calibra, and it's Elation, and it's Databricks Unity, and it's Purview. And what are knowledge graphs good at? We talked about this earlier. Bringing together disparate data sources in different technologies from all across the organization, and catalogs are no different. So knowledge graphs also provide an interesting capability within data management by bridging the silos of data management functions, the different parts of the organization that do governance, and how you end up with different catalogs. So that's why we focus a lot on making our solution overlay over top of all of these catalogs, so you get that comprehensive view of the knowledge catalog across your entire enterprise. And
that probably extends to the other question or topic I had about data fabrics and data mesh, I guess, but in the distributed environments. Mike, maybe you could talk a little bit about how that knowledge graphs play in that, or their role.
I mean, I don't want to sound like a broken record, but I mean, they're foundational because at the core of the data product, what we're trying to describe is a particular part of our world that makes sense, that's important for us, that addresses some particular problem or challenge that the organization faces. That may or may not span silos, that may or may not span departments. That's kind of the point of the mesh and the fabric, bringing that stuff together into these singular data products. We should just start calling them knowledge products, maybe. Maybe that would be my contribution. because that's really what they're about, is finding the knowledge of the organization that was otherwise disconnected, hidden, latent at best in these kind of dark corners of the organization in between silos.
Great. You know what, Andrew, why don't we see if there's any audience questions? I know that we're kind of at the top of the hour here, so let's switch to that and see what we can do.
Yeah, we'll try and squeeze one audience question here. I'd love to get all three of your perspectives on this, if you can, our speakers. Perhaps we'll start with Sean here, and then we can go to the others. So Sean, would love your take on how to handle the data quality issue. This question is quite lengthy here, so let me read it out. The quality of the data used to build the knowledge graph can significantly impact its accuracy and usefulness. Poor data quality can lead to incorrect or incomplete information being stored in the knowledge graph, which can result in unreliable insights. So how would you handle that issue?
My old answer used to be there's no magic. It's the same problem you have with any database you're going to build, and you're going to worry about data quality. But I'm now having to learn new tricks. Despite my gray hair, I think the LLM stuff is going to help enormously with data quality. And we'll be working on, you'll be seeing stuff from us around that. So there is now magic. And mapping is the other thing everybody hates, right? That's another area where I think this is going to be hugely transformative.
Yeah, I think one, just to kind of also tie into the last question about catalogs, this idea of a knowledge catalog reaching across the entire organization, it gives you at least the ability to select the right data. If I'm sending something to the federal government, I want to select only the golden sources. Just knowing what sources of the golden sources can be challenging when you don't even have the list of all the sources all in one place. So knowledge graphs can enable people to make better, more informed choices about what data they're using, how it can be used, better explainability, because you understand where that data came from, the full life cycle of it. And then we understand the precise meaning of data. I think that makes data quality challenges easier to address, because there's no ambiguity about what the data means. And I agree with Sean, LLMs provide some interesting options in this area, because we can communicate more effectively with how we want that data to be changed, what it should look like, what our expectations are.
A slightly different take, I think. Agree with the first half of what everyone's saying, where, well, primarily like data quality, the knowledge graphs, particularly ontologies, enable you to have one of the best data quality engines ever, right? If you actually define a really good ontology, your data can be governed by it. When you govern your data against against an ontology, it can actually say, hey, these social security numbers are only allowed to have this number of digits, or kind of some of the basic elements of data quality, which still are difficult to do. I think LLMs, are interesting. I don't know if they necessarily only positively impact data quality. I think they're important. I think that you can get a lot of really interesting data quality solutions from it. I think it also increases the type 2 error in data quality. You can end up having a lot of information, some of it right, some of it not, some of it ungoverned. Workflows and tools that can help enable the enhancement of your knowledge graph in a kind of structured way, provide you kind of a ballast or some sort of tool set to enable appropriate adding and updating of your knowledge graphs. So I think LLMs are interesting in that sense. I think the real promise of LLMs allow you to actually imbue more and more information and meaning contextually without needing highly technical skill sets. But I think in my view, in our view, the jury's still out if they're going to be universally valuable for quality specifically.
Well, that was fantastic. I do think we could probably keep going, having the four of you on this topic for a lot longer, but unfortunately we have run out of time for today. So please allow me to thank our speakers. We did, of course, hear from Dave Stoddard with TDWI, Sean Martin from Cambridge Semantics, Michael Grove from Stardog, and Nimit Mehta of Top Quadrant. I would also like to thank all three of the companies for sponsoring today's webinar as well. And please remember that we did record today's webinar, and we'll be emailing you a link to an archived version of the presentation, which you can feel free to share with colleagues. And if you'd like a copy of that presentation, you can check the resource window. Finally, there's just a few weeks left to join us at TDWI Nashville, taking place May 14th through May 19th. You can learn from vetted instructors on topics including data governance, machine learning, data fabric, dashboards, and more. You can save 30% off your first TDWI event with promo code FIRST30. That's FIRST30 by May 12th. View the agenda at tdwi.org/Nashville, and we hope to see you there. Lastly, from all of us here, let me say thank you so much for attending. This does conclude today's event.